In this video, let's talk about finding the area under a curve. So in this case, our curve is the quantity 1 minus cosine x multiplied by sine of x. And we're integrating over a region 0 all the way up to pi. So what I like to do here is draw out an infinitesimal slice with some width dx and some height y. So what we're doing is we're adding up all these slices going up to pi. And that's what the integral function does. So we're doing the integral from 0 to pi of the height, which is 1 minus cosine of x multiplied by sine of x dx, which is the width. So what we can do to solve this integral now that it's set up, which is the hard part, is use a u substitution. Our u variable is going to be cosine of x. So that means du is equal to negative sine of x dx. And what I did there is just take the derivative. And I like to rearrange for dx. So dx is equal to du divided by negative sine of x, right? And then let's go ahead and solve for the bounds in terms of u. So the lower bound, u lower, is going to be cosine of 0, which is equal to 1. And the upper bound, u upper, is equal to cosine of pi, which is equal to negative 1. With all these things together, we could make those substitutions. So we have the integral from lower 1 up to upper negative 1 of 1 minus, and since cosine of x is u, we just do u here, times sine of x. And then dx is du over negative sine of x. So we can cancel here, and this negative sign sticks around. And I'm going to go ahead and put it in here. So we have the integral of 1 to negative 1 of u minus 1 du. And this is easy to solve. The antiderivative here is u squared over 2 minus u. And we need to evaluate over those bounds from negative 1 up to 1. 1 up to negative 1. So plugging in the upper bounds, we have negative 1 squared over 2 minus negative 1. Then subtract 1 squared over 2 minus 1. So what we do here is 1 squared is 1, or negative 1 squared is 1, so we have 1/2. Minus negative 1 is plus 1, and then distribute this in, so we have minus 1/2. And then minus minus is plus 1. These minus 1/2s cancel, so we have the answer of the area under the curve is 2 units squared.